All right, so we're gonna get going. All right, so you should be able to see my screen. So let me go over to the screen. So, all right, can someone just confirm verbally that they're seeing the screen because I'm not looking at the Google.
Yes, sir.
Okay, great. All right, so this question here is a paper 3 question. It's the January, no, not January, but June 2011 paper 3. So you can make a note of this. If you have access to this paper, right, you can, after completing this, you can actually attempt it, or if you can get it open in front of you right now as we go through, that will also be good. So here's our question, right? And for those, well, I know Daniel is preparing for paper 3. For the paper 3, it is a lab-based exam, right? So you're required to uh, do a lab practical in the exam, right? As well as some other questions related to the laboratory aspect of physics, because a key part of physics is being able to show that you have mastered certain experimental skills. So this paper, the paper 3, is actually what tests that. So for those persons who are doing paper 2 and paper 1 only, they will be doing their practicals and so on. So the paper 3 is basically the practical for private candidates. So let's look at this now. So it says now that the arrangement in figure 1 was set up to find out how image distance and object distance were related for a convex lens, right? And you can see that we have our setup right here, and we have what looks like a grid paper with some measurements in centimeters, and we have object at a certain position, we have a lens at a certain position, and we have a screen at a certain position. But before we go into this, let us, start to talk a little bit about in terms of lenses, especially the convex lens. Do we know anything about the convex lens? What do we know about the convex lens? Anybody? Anybody? Say something, please. What do we know about the convex lens? Can you guys hear me? I'm not hearing anything from anyone. Can you all hear me?
Yes, sir. I can hear you, but I don't
Okay,
know.
okay, yes. So what do we know about the convex lens? What do we know about, we know anything about the convex lens?
No, sir.
Okay, all right. So a convex lens, we can make a note of that. So let's make a note of that. So a convex lens is a type of lens, or another name for the convex lens is our converging lens. Converging lens, right? So the convex lens is also what is referred to as the converging lens. And as the word converge, what does the word converge mean? What does the word converge mean? Anybody? All right, to meet at a point. Very good. So to converge simply means to meet at a point. So in other words, it's like things coming together, so to speak. So with a converging lens actually works to allow light rays to come to a point, right? So we can make a note that a converging lens is a type of lens. So I'm just going to put it on right here, a type of lens that allow light rays to converge or meet at a point. All right, hopefully this writing is this writing legible enough? I know I'm just trying to squeeze it in right here. Is the writing legible enough to you guys on your end? Okay, good. Okay, thank you. So a converging lens, it allows light rays to converge or meet at a point. All right, and there are some very interesting thing about converging lenses that we can talk about, but for the sake of keeping this a short presentation, we're going to just accept and move forward with our definition for the convex lens or the converging lens, right? So, and as I go through, if there are any questions, please let me know, or make an alert, something. If I say something and you're not too sure, let me know so I can go back over it. Sounds good?
Yes, sir.
Okay, thank you. All right, so now we have our setup right here. We have an object right here. And what will happen is that light rays from this object will strike this converging lens. And this converging lens will allow those light rays to converge or meet at a point, right? And they're going to meet at a point somewhere in front of this lens. We expect it to be on this screen. So therefore, what will happen is that we will have our object right here, and we'll be able to see an image of our object on the screen. So that is what we will observe in this case. So let us start answering our question. So here, it says, the first thing that they say is we are to record the position of the object, the lens, and the screen. So again, we have our scale here, right? We have our scale measured in centimeters, and we have our object at a certain position. The lens is at a certain position, and our screen is also at a certain position. Now they want us to record these different positions. All right, so let's start with the object. What is the position of the object? What is the position of the object? Huh? 2.4 centimeters. Okay, let's look. Okay, so we have our scale right here. So we have 0, 1, 2, and then this is 3. So if we have 1 right here and then 2, right, it means then that this is 1, 1.2, 1.4, 1.6, 1.8, and 2, right? So therefore, each of these small lines, right, actually represents 0.2 centimeters. So right now, our object is at the second mark after our 2 centimeter mark. So therefore, it's 2, 2.2, and 2.4. So you're correct, Daniel. This is 2.4 centimeter. That's the position of our object. Now, the next thing we need to find out is our lens position, right? What can we say about the position of the lens? Welcome, Duffus. Welcome. Hopefully you're here to be a part of our physics session. Can you just post something in the chat or make a sound so I know that you're ready to learn something? Okay, so we're saying 7.4 centimeters. Let me check that. Okay, right, so we have 7 right here, 7.2 and 7.4. So we can record that as 7.4 centimeter. And then finally, we need to know our screen position. Can anyone tell me where is the screen position? What's the screen position right now? All right, let me see if I can join on my phone. 15 centimeters, okay. So 15 centimeters, right, is correct. So we say 15. Let me use a different color. You can say this is 15 centimeter. Right? Is that clear to everyone? This makes sense?
Yes, sir.
Okay, good. All right, so we have just recorded the position as was requested of us. All right, so now the next thing we can do now is moving forward. They want us to state a precaution to be taken when reading the scale. All right. So what would you say in this case would be a suitable precaution that we could take? What sort of precaution would we take? Usually when we're taking measurements, right? Especially when we have to, okay, read the scale at eye level to reduce parallax error. Yes, very good, right? Whenever we're taking readings, especially of something that we have to look at, analog instrument that we have to look at and read off by where the markings are, we will always want to ensure that we are reading at eye level, as what Daniel says here, to reduce parallax error. Right, so we can make a note of that. So we could say, ensure the scale is read at eye level, and this is to reduce parallax errors, right? And parallax error is a very common error, especially when, as I said, you have to view something, because you have to ensure that you actually position your eye at the right point so you can obtain your accurate measurement. All right? Any questions? Questions? Yes, sir. Is that a yes? Okay, no question. Any question, Sabrina, Karagina, and Jan, any questions from you? Okay, cool. All right, so I'm gonna join on my my phone as well, so I can keep track of the comments in the chat, because I don't want to miss any of your questions as we go through. So let me just join again. What's this thing again? Physics. All right, so give me a second. Let me just join here, and then we will continue. All right. So are you guys making notes of this, taking down information? Okay, good. All right, so let me see if I can join here. All right. Okay, is the sound good on your guys? On your end, guys? I need to. Okay, cool. All right, so I need to open the chat so I can see here. All right, so messages. Okay. All right, so I'm able to see the messages as you post them in. All right, so enough of that. Let's get going with what we need to get going with. So we've just completed this question, so we can scroll forward. So we will move down, right? And now it says we're to calculate the image distance V and the object distance U for the arrangement in figure 1, and enter these values in their appropriate spaces in the table below. And this is our table, right? And as you can see, it is missing 2 values for V, which is our image distance, and U, which is our object distance. So they ask us here to calculate the image distance V and our object distance U based on our arrangement. All right, so what we'll have to do is we will have to go here back to our setup and calculate these distances. So we will first define the image distance, right? The image distance is defined as the distance. Hold on a second. So the image distance is defined as the distance between the lens right here and the screen, right? So this right here will be our image distance. This distance from the lens to the screen will be our image distance V, right? While the distance from our lens to the object, what do you think we will call this distance right here? From the object to the lens. What would we call this distance here? Object distance, right? So this will be our object distance, right? So we can use our information in the table here to help us to calculate these, right? How could we calculate our object distance after knowing the position of the object and the position of the lens. How can we calculate this distance? Huh? Any ideas? Okay, so what we're saying is that we have our position of the object right here. It is 2.4 centimeters, and the position of the lens is 7.4 centimeters. So the question I'm asking you now is how could we be able to, or how would we be able to calculate this image distance u, which is the distance from our object to our lens? How could we calculate this distance here, knowing the two positions of the object and the lens? Any ideas? Any ideas? I'm watching the chat, waiting to see if someone will be able to assist us. We want to find our object distance u, right? We know the position of the object and we know the position of the lens. So how can we calculate this distance here? Any ideas, please? Any ideas? Okay, all right. What if we say our object distance u, right? So as I said, we know the position of our object. It is at 2.4 centimeters. And we know the position of our lens, it is 7.4 centimeters. So we can calculate this distance right here, u, by subtracting the object position, well, object position from the lens position. So what we'll say is that u is equal to our object position, our lens position, I should say, sorry, lens position, and subtract the object position. So we're going to say lens position is 7.4 centimeters, so we have 7.4 centimeters minus object position, which is 2.4 centimeters, right? And this is equal to what? What will this be equal to? Huh? What will this be equal to? 5, right? Right? So this will be equal to 5 centimeters. So our object distance would be 5 centimeters. Because what we're saying is that the object, which is this right here, is 5 centimeters away from our lens. Is that clear? Let me know if that is clear, please. Okay, good. What about the others? Can you confirm that this is clear? Are you following what's going on? Okay. All right. So we have just calculated our object distance. It is 5 centimeters, and we can do the same thing to calculate our image distance, right? The image distance is right here from the lens to the screen. So we'll say that our image distance V is equal to the screen position minus the lens position. Right, so it's going to be the screen position, subtract the lens position. So we'll say 15 centimeters minus 7.4 centimeters. Can someone help me to calculate this, please? What will this be equal to? $7.6, okay. So we get 7.6 centimeters. So we would have just calculated our object distance and our image distance, right? So we'll actually do this calculation down here, right? Where is it? Here, right? So we'll do the calculation right there. So we'll say u is equal to, what was it again? 7.4 centimeter minus 2.4 centimeter, which is equal to 5 centimeter. That's for our object distance, and then v, our image distance, is, I think it was what, 15 centimeter minus 7.4, and we got 7.6 centimeter. That makes sense? That makes sense? Okay, perfect. So now what we'll do then now is just simply fill in our values in the table, right? So our image distance, which is V, is 7.6 centimeters. So we'll write it in 7.6, and we don't have to include centimeters because it is in our heading of the table. And then our object distance now, U, is simply 5 centimeters. So we just write it in as 5. And this will be our table completed, right? So what we're going to do now is we're going to now actually plot a graph, right? So we're going to use this data here to plot a graph, because they say here to plot on page 5 a graph of the image distance V against the object distance, right? So we're plotting image distance against object distance. Does everyone have their graph paper ready? Okay, Daniel has her graph paper, okay. Sabrina, oh yes, yes, yes. Jayan and Karagina, you guys have your graph paper ready? Huh? Okay, all right, so we will now talk about plotting our graph. So they say we're to plot a graph of image distance against object distance, right? So we now need to determine which quantity will need to go on the y-axis and which quantity will go on the x-axis. And then after determining that, we will then have to choose an appropriate scale to plot our graph. So first thing we need to do is to determine what goes on the y, what goes on the x. So which of our quantity, image distance or object distance, would we place on the y-axis? Okay, image will go on the x-axis. Okay, everyone agree? Everyone agree that the image distance will go on the y and the object will go on, image will go on the x and the object go on the y? Everyone is in agreement? Everyone is in agreement? Image distance goes on the x, object distance goes on the y. Everyone agrees? Okay. Okay. Oh, well, on the topic we're on, okay, the topic we're on, Karagina, we're looking at a paper 3, right? And we're just going through the question with the intention of understanding exactly how to answer paper 3 questions. I'm not sure if you may or may not be doing paper 3, but the session here will just ensure that you're able to actually sharpen up your skills on certain areas. So we're actually looking at a complete past paper, Karagina. All right, so I just saw that Daniel said no. Okay, cool. So the question is again, we need to determine what goes on our y-axis and what goes on our x-axis. And we're plotting a graph of image distance against object distance. So my question again is, what quantity will go on the y and what quantity will go on the x-axis? Huh? Any ideas? Please, I want us to engage. So if it is that you can post in the chat, right, and let me know what you're thinking. So if there are any misconceptions or anything that we need to address, we can clear them up. So I saw where Daniel had made an attempt, and she went ahead and now says that she wants to change her earlier viewpoint. So what are you changing your earlier viewpoint to, Daniel? Huh? Does anyone have any idea as to what will go on our y-axis and what will go on x? Okay, so I think object is x and image is y. And okay, so now you're saying that the object will go on the x and the image go on the y. Okay, very good. Right, this is actually what we should expect, that based on that the image will go on the object will go on the x and the image will go on the y. Now let me tell you how we come to that conclusion. So when the examiner, or when they ask us to plot something against something, right, the quantity that comes first will always go on the y-axis. So whatever comes first will always go on the y-axis, right? And whatever comes second will go on our x-axis. Is that clear? Right? So whatever comes first in the statement will go on the y-axis. Okay, cool. Okay. I understand. I'm correct, Gina. Afterwards, I will send out the recording, so you might be able to check it out afterwards, right? So whatever comes first will go on the y-axis, and whatever comes second will go on our x-axis. So therefore, this means that we will plot image distance, which is v. This will go on our y-axis. So I usually like to make a note here, right? This will go on the y-axis, and here will go, object distance will go on the x-axis. So this is what we need, right? In terms of which quantity go on the y and which quantity go on the x to plot a graph. So they say we need to plot image distance against object distance. So we now need to choose an appropriate scale. All right, we now need to choose an appropriate scale. So when choosing the scale, you want to always take a look at the range of data that you have to plot, right? So you're plotting from 7.6 to 80 on the y-axis. So we'll need to choose a suitable scale that can allow us to do so, right? So in this case, because these are large numbers, I like to use the scale 1 to 1, 1 to 2, 1 to 5, or 1 to 10. Any one of these scales should be able to work in our case, right? Either 1 centimeter to 1 unit, 1 centimeter to 2 unit, 1 centimeter to 5 unit, or 1 centimeter to 10 unit. All right? So we can use any of these, and we'll be able to scale our graph, right? And usually scaling the graph is sort of a challenge for persons. So we will be able to discuss that in more details. But are there any questions in terms of what I would have said so far? Any questions? Any questions from anyone? All right, let me go. Okay. All right, any questions? All right. Okay, cool. All right, so let us look at our graph now, and we're going to just do sort of a trial and error when choosing the scale. So we're going to say, this is our graph paper. We're going to say we're going to try maybe 1 centimeter to 1 and see if that will allow us to plot up to 80. So we'll say this will be 0 right here. So we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this would not allow us to plot our graph based on the range of data that we have, because we need to plot from 7.6 to 80. So we can try 2. So let us try 2 and see what happens. So if we say 1 centimeter to 2, we will say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. So therefore, that scale would not work either. So we can try 1 to 5. So let's see for 1 to 5. So at 1 to 5, we'll say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So do you think that this would be a suitable scale that we could use? Okay, perfect. So we can use that scale, all right? So we can definitely use that scale. All right. So we will use our scale on the y-axis. Let's just make a note of that. That the scale on the y-axis we will use is 1 centimeter equal 5 units. Right? That's the scale on our y-axis. And again, on the y-axis, we're plotting. What did they say we need to plot on the y-axis again? Image distance, right? So we're plotting image distance, and that is v. So image distance on the y and we have chosen our suitable scale. So now let us now determine a scale for our x-axis. So we'll go back to our table and we see for the x-axis, we need to plot from 5 to 124, right? So we're going to use this ratio again. I won't bother go through these because these will not work because they didn't work for the y-axis, so they're definitely not going to work on the x-axis. So we're going to try 1 to 5 and see what happens. So with 1 to 5, we will say for each centimeter, we'll say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So that's not going to work. Right, so we can try 1 to 10 and we'll say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Right, and we need to plot up to 124. So do you think that 1 to 10 would be a suitable scale for the x-axis? Okay, okay, good. So for the x-axis, again, we're plotting object distance, and that is u, and we're using a scale of 1 centimeter equal 10 units. So now, what we're going to do now, again, if you guys haven't copied down this table here, I want you to take down these values because I'm going to ask you to plot your graph individually, and then we're going to talk about it together. All right? So do you need some time to take down this information? Do you need some time to take down the table? Yes, no? I just need some responses in the chat. Do we need to take down the table? Do you need time to take down the table? Okay, perfect. All right, so what I'm going to do, I'm going to start to rule up my graph. And in the meantime, I'm going to ask you to individually plot your graph. And then we're going to talk about the graph a little later. All right, so let me just set up my graph paper and then we will plot the graph and then talk about it shortly. How is this session going so far for you? How is the session so far? Are you following? Is this good? Okay, perfect. All right, and again, if there are any questions, anything that I say that doesn't make sense or you're not too sure about, let me know. I'm more than happy to go over accordingly. Okay, okay. That's good, Sabrina. That's good. All right. So this is our y-axis, and this is our x-axis. All right. So I want you to, as I said, get your graph paper and then rule up your graph paper and then plot the points. We're going to talk about plotting the points as well. So let me just rule up mine. So 1 centimeter to 10. So I'm gonna because of the space right here, I'm gonna just multiply the scale by 2. But if you can use 1 to 1 in your case. So don't be too surprised if you're seeing that I'm using 2 centimeters. I want you to use 1 centimeter to 10 in your case, but it will be the same as what I'm doing here. So I will say this will be 20 here, 40, 60, 80, 100, 120, 140, and 160. All right, so I want you to scale up your graph, and then we're going to talk about plotting the points. So here, 1 centimeter to 10. So if I go 2 centimeters, that would be 1 centimeter to 5. Sorry. So if I go 2 centimeters, it will be 10. So I'll go 10 there. 20, 30, 40, 50, 60, 70, 80, and I can continue. 90 and 100. All right, so I've just ruled up my graph paper. Have you all done the same on your end? Have you ruled up your graph paper and ready to talk about plotting the points? Let me know, please, if you have finished ruling up your graph paper, and then we can now talk about how we go about plotting our points. Let me know, please. I'm waiting. I'm in the chat to see what's going on. Are we still ruling up the graph paper? Okay. Daniel just finished. Okay. So let's probably wait about another minute to allow the others to finish as well. Okay. Let me know if I need to wait a little more before beginning, or before continuing, I should say. Can we continue? Sabrina, let me know if you're ready for us to go. Okay, cool. All right, so with our graph paper ruled up, we're going to go back to our table. All right, we're going to go back to our table to see the values that we need to plot. So again, we're plotting image distance on the y-axis and object distance on the x-axis, right? And these are the coordinates for the points that we will plot. So we need to find a point that corresponds to 7.6 on the y-axis and a point that corresponds to 5 on the, 7.6 on the y-axis and 5 on the y-axis. Let me go back at it again. So we need to find a point that corresponds to 7.6 on the y-axis and 5 on the x-axis. Oh, by the way, one more thing. Notice that we have a unit here. We need to include these units when we indicate our scale. So here, I should say 1 centimeter to 5. This should be centimeters. So make that correction in your thing, centimeters. And similarly, this will also be centimeters, because we need to indicate our units where necessary. All right. So now we need to find 7.6 on the y-axis and 5 on the x-axis, and we can use either dots in circle like this to plot our points, or we can use small x's like this. In this example, I'm going to use small x's, so you can use small x's yourself, or you can use dots in circle. Either of these is okay. All right, so let's know. So 7.6 on the y and 5 on the x. So let's look for that point. So first we'll find 7.6 on our y-axis. So we have 5 here. So each of these small lines is actually 1. So this is 5 right here, 6 and 7. So we have found 7. Now they want us to find 7.6, and 7.6 corresponds to 5. So now we find 5 right here, 6, 7 on the y, and 7.6 would be somewhere in between here, right? So we can estimate that shortly. So we're going to talk about estimating that point. Now let us look for 5 now. So here now we have 0, this is 10. So halfway between here, we will find 5. So we can also estimate that. So I'm going to say, okay, this is this is 1, this is 2, 4, and 5 would be somewhere in between here. So I'll have 5 right here. This is 7 here, and 7.6 would be somewhere here. So it's going to be somewhere here. So in this case, what we're doing is we're reasonably estimating this point, right? So it must correspond to 7.6 on the y and 5 on the x. So 7, this is 6, this is 7. So 7.6 must be somewhere in between 7 and 8. Similarly, we're trying to find 5 on the x. This is 0 and this is 20. This is 10. So halfway in between here would be 5. So that is why we estimate that our point will be here. So 5 will correspond right here and 7.6 right here. Is that making sense? Let me know if that is making sense to you guys. Okay, cool. So now let us move on to our next point. So the next point is 20 and 30, right? So 20 on the y, 30 on the x. So this is 20 on our y-axis, and 30 on the x would be right here. So we're going to place our point right here. So this point is quite nicely situated. So we get a nice looking point exactly on the line like that. All right. Then now we'll continue. So we'll continue. This is 40 and 62. So we'll find 40 on the y. So this is 40 on the y. 60 is right here. So 40, right? This is 60. So this would be 62 would be our first point. So we'll place our x right here. And if I'm going too fast, please let me know so I can revisit. What we're doing right now is we're just finding the points based on the scale that we use. So this is 60, 62, 64, 66, 68, 60, 62, 64, 66, 68, 70, so on and so forth. So we get 60 right here. 62 would be our first point and it corresponds to 40. Then now we continue and we say 60 must correspond to 87. So we find 60 on our y-axis, which is right here, and it must correspond to 87. So let's scroll on a little bit. So 60 is this line, 80 is right here. This would be 82, 84, 86. So 87 will be a little before we reach 88. So it's going to be just right here. Then now we will continue with our last point, which is 80 and 124. So we'll find 80 on the y-axis and 124 on the x. So 80 is this line right here. We have 120 right here. Well, 80 is right here. And we have 120. This would be 122, 124. So it's going to be right here. Is that making sense so far? Is this making sense? Okay, cool. So then now, what after plotting these points, we will now have to determine or draw our line of best fit. So we'll have to take our ruler, our straight edge, and we will line it up. Preferably when you're doing your best fit line, you want a clear ruler, so you can actually see how the points are situated about the line that you intend to draw. So when I'm doing my line of best fit, I always aim to ensure that I have an even distribution of points about the line. So that means I want, if not having all the points sitting on the line, I want to have an equal distribution of points about the line. So if I have 2 points on one side, I want to have 2 points on the other side, and their position must be reasonably the same distance on each side. So here I have a situation that almost achieves that. So I have 2 points on this side and 2 points on this side as well, and it actually passes through this point directly. So now I will now draw this as my best fit line. So I'm going to use my yellow and just draw this as my best fit line like that. All right, is that clear? Okay, cool. So this is our best fit line, and then finally, to complete our graph, we need to state a title. So when writing your title, you want to simply say graph showing whatever is on the y-axis, in this case, image distance. So we'll say image distance versus or against whatever is on the x, which is our object distance, object versus object distance. Yes, the title has to be in full caps, and then you will underline your title like this. So sorry for the chaka thing up here. I mean, as when you're doing an exam, you want to ensure that it is neatly done. So let me apologize for that. All right. Yes. So this is it, and then we would have completed our graph, right? And in this case, this graph worth 10 marks. So it's a huge chunk of your marks that you will be vying for in your exam. All right. Any questions on this? Any questions? Okay, cool. So now we can move forward to the next thing. So the next thing now they say now, use the graph to state the relationship between V and U and justify your response. All right. So for this, they say we need to use the graph. So once they say use the graph, we need to actually look at the graph to obtain some information. And in this case, they want us to obtain some information about the relationship between V and U, which is our image distance and our object distance. So if we look at our graph again, right, we see that we have a positive sloping diagonal line, right? Whenever we have a positive sloping diagonal line, we can say that the relationship that exists between these two quantities that we plot, image distance and object distance, is a proportional relationship, right? It could be either proportional or directly proportional. If it is directly proportional, we will have our line passing through the 0 mark or the origin. In this case, because this line, this best fit line, doesn't. Okay, see, okay, perfect. Okay, cool. So you're able to follow along. So we have our line of best fit, which is a diagonal line. It is positively sloping. So we say that it shows a proportional relationship because it doesn't pass through the origin. If it had passed through the origin, we would say that it is directly proportional. That makes sense? Does that make sense? Okay, cool. So we say that this is proportional. So we can now answer our question here to say that the image distance V is directly, no, not directly, sorry, not directly, but proportional, is proportional to the object distance U, since we obtain a positive sloping diagonal line that does not pass through the origin. All right, is that clear? Is that clear? Okay, cool. So now we say it doesn't pass through the origin, which simply means it doesn't pass through the 0 point, which is what we observe right here. All right. So if there are no questions, we will continue. Okay. Okay. Oh, we're not finished as yet. They say using the graph or otherwise calculate the magnification of the lens. So let's look at that now. So when dealing with the magnification of a lens, so magnification, I'm going to write it out in words. Magnification of a lens is equal to the image distance, right, or image size divided by the object, object, distance, or size. Right, so you want to write down this formula right here. Magnification, and the symbol for the magnification is given as M, right? And we know from before that our image distance is V, and our object distance is U. So we have a formula which says that magnification M is equal to V over U. Now, based on this graph right here, we have image distance against object distance. Right, so we plot image distance against object distance. So what we can do is we can find the gradient of this line, and the gradient of this line will give us the magnification. Right? So we're going to say that the gradient, I'm going to write it as slope. The slope of the gradient is equal to y2 minus y1 divided by x2 minus x1. So now, to find the magnification, right, we will simply select 2 points on the line. So I'm going to select a point. I'm going to select 2 reasonable points. I'm going to select a point right here. And I'm also going to select a point right here. So these are the 2 points I'm selecting. And what I will do, I will take a ruler and draw broken lines. So let me do that in quickly. If I'm going too fast, let me know. So I'm going to take a broken line like this and quickly draw down like this. Do the same thing here for this point. and a broken line like this all the way down, and then I will simply do the same thing to obtain the y values. So I'll go across like that, and for this I will also do the same thing and just go across just like that. So now what I will do now, I will just simply read off. So I will get y2 from here and x2 from here, and I will also get y1 here and x1 here. So let us read off y2 and y1 quickly. So in this case, we get y1 here. So what is y1 equal to? We're going to read off on the y-axis. What is y1 in this case? What would y1 be? Based on my graph, what would y1 be? Huh? Okay, so y is 90. Okay, so you're saying y2 would be 90. So let me record that as 90 centimeters minus, what about y1 now? What would y1 be in this case? 10. Okay, so we're going to get 10 centimeter divided by x2. x2 was given earlier as 140. So 140 centimeter. And x1, what's x1? What's x1 right here? No, not 20. Not 20. This is 20 right here. X1 would be right here. So what would this be? 10. Very good. So 10 centimeters. So now we can do some calculations. So 90 minus 10 is 80 divided by 140 minus 10. This is how much? 140 minus 10 is, that's what? 130. So now we can now simply divide this. So we're going to divide this and say 80 divided by 130, right? And we get 0.0.62, right? Writing it to 2 decimal place, so we get 0.62. And in this case, we're not going to get any unit. We'll just simply get 0.62. All right. Let me just see something. Okay. So we get 0.62. So therefore, since we get a value, whenever we're doing magnification calculations and we get a value less than 1, it means that the image size or image distance is, let me just double check something here. Right. So it means that whenever we have a magnification less than 1, it simply means that the image distance, right, is less than the object distance, right? And we saw that in our table, that for each, this is our, wait a second. Our image distance and our object distance. Okay. All right. So we get a value of 0.62 when we find our gradient, and that actually represents our magnification, right? So the magnification is equal to 0.62, right? The magnification of our lens is 0.62. Let me just double check something here. Let me just double check here. Okay, so all right, so okay, did they tell us the focal length? Let me see if they told us the focal length. Okay, they didn't tell us the focal length. All right, so that would be our question completed. Any questions? Any questions here? Okay, all right.